Okay, sixth graders, we're getting now into lesson 7.5. We're going to be focusing on finding the surface area of rectangular prisms, finding the surface area of triangular prisms. Now remember, in yesterday's lesson for 7.4, we focused on prisms and we talked about how a prism had two bases of a specific shape, which was what named the prism, and then everything else was a rectangle. So this is a rectangular prism, and so if I look at the front and the back as rectangles, now I understand my drawing is not perfect, but you need to imagine that the front and the back are the exact same, the bottom and the top are the exact same, and the right and the left are the exact same. You're just going to have to use your imagination, but I think you can handle that. But if I have two rectangular bases, if the front is a rectangular base, the back is a rectangular base, and then all I'm doing is connecting it with rectangles. Rectangle at the top, rectangle at the bottom, rectangle at the right, rectangle at the left. Now, when I think about surface area, I equate surface area with like wrapping a present, when you might give a student or you might give a friend or a family member a birthday present or a Christmas present. And you want to have the exact amount of wrapping paper to wrap that gift or that box that the gift is in. That's surface area, okay? Like if I was to wrap a box this size as a gift for my son or daughter or my wife or somebody, that's a big present, by the way, 11 feet, but that's a whole different topic. I would have to figure out the surface area of this box to have the exact amount of wrapping paper that I needed. And when I talk about surface area, basically I'm talking about finding the individual area of all the faces. You'll remember in yesterday's video, when we talk about prisms and pyramids, the face is the flat surface. So this rectangular prism has 6 flat faces or flat surfaces: the top, the bottom, the right, the left, the front, the back. Okay? And so those are the flat surfaces. To find the area of a rectangle, the formula is area equals length times width. Okay? And so it assumes that you understand that. That should not be a new formula to you, but we just want to review that just in case. So if I'm looking here, first of all, the first thing I want to figure out and remember in my mind is that if the bottom and the top are the same, I should only need to figure out that once. The bottom here, the length is 11, the width is 5, and 11 times 5 is 55. So if the bottom is 55, then that tells me that the top is also 55. So I should make a note of two 55s. Now if I'm looking here at the right, I see that it's 5 times 8. It's 5 feet long, 8 feet wide. 5 times 8 is 40. But if the right is 40, then the left is also 40. So I need to have two 40s on my list. When I look at the front and the back, I look at this shape here. Well, this is 11. There's no measurement here, but I can see from here that if this is 8 and this is a rectangle, then this also has to be 8. So this is 11 times 8, which is 88. So if the front is 88, the back also has to be 88. So I come over here and I put two 88s. Now I have to add all these together. Well, 5 plus 5 is 10, still 10, still 10, plus 8 is 18, plus 8 more is 26. So I'm going to put the 6 down and carry the 2. Well, 2 plus 5 is 7, plus 5 is 12, plus 4 is 16, plus 4 is 20, plus 8 is 28, plus 8 more is 36. And since we're talking about area, even though it's surface area, everything is square units. You'll remember that area is always square units. Okay? 366 square feet. We were talking about earlier this chapter, areas of different things. Area is always square. 366 square feet. All right, well, let's look at another example of a rectangular prism. And so here's one here, but it's the same idea. It may not look exactly the same, a little taller, a little skinnier, 6.2 meters, 4 meters, 11.7 meters. Well, if I want to deal first with the bottom and the top, it's going to be 6.2 meters times 4 meters. Sometimes you're going to have to do a little scratch work. Okay, it's not all going to be mental math like in the first one necessarily. 6 2/10 times 4. 4 times 2 is 8. 4 times 6 is 24. One digit after the decimal in the problem, one digit after the decimal in the answer. So the top, or the bottom and the top, are 24.8. Now, if I'm looking at the right and the left, looks like 4 meters long, 11.7 meters, 11 7/10 meters wide. So that's going to be 11 7/10 times 4. Well, 4 times 7 is 28. Put the 8 down, carry the 2. 4 times 1 is 4, plus 2 is 6. 4 times 1 is 4. One digit after the decimal in the problem, one digit after the decimal in the answer. The right and the left are both 46.8. Well, if I'm going to do the front and the back, it's going to be 6.2 here. And just like on the previous one, there's no measurement on either of these edges. Okay, you'll remember from yesterday's that each of these lines is called an edge. But if this is a rectangle over here, if this is 11.7, this also has to be 11 7/10. So to figure out the front and the back, it's going to be 11 7/10 times 6 2/10. So 2 times 7 is 14. Put the 4 down, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2. Put the 0 down. 6 times 7 is 42. Put the 2 down, carry the 4. 6 times 1 is 6, plus 4 is 10. Put the 0 down, carry the 1. 6 times 1 is 6, plus 1 is 7. And I've got 234, 7,020. I'm going to add those numbers. 4 and 0 is 4. 3 plus 2 is 5. 2 plus 0 is 2. Nothing and 7 is 7. There are 1, 2 numbers after the decimal in my problem, so I need 1, 2 numbers after the decimal in my answer. I get 72 54/100. Well, remember what I'm doing is trying to find the surface area. So this was the area of the bottom and the top. So on my list, I need 2 that are 24 8/10 for the bottom and the top. This 11.7 times 4 was for the right and the left. That was 46.8. So I need 2, 1 for the right, 1 for the left. That's 46 8/10. The bottom, the front and the back was the 11.7 and the 6.2, which worked out to be 72 54/100. So 72 54/100, and another one, 72 54/100. So I have the top and the bottom, the right and the left, and the front and the back. So we need to go ahead and add all these numbers. We have each of the 6 faces. Now I need to add them. 4 plus 4 is 8. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 5 is 37, plus 5 is 42. Put the 2 down, carry the 4, drop the decimal. 4 plus 4 is 8, plus 4 is 12, plus 6 is 18, plus 6 is 24, plus 2 is 26, plus 2 is 28. Put the 8 down, carry the 2. 2 plus 2 is 4, plus 2 is 6, plus 4 is 10, plus 4 is 14, plus 7 is 21, plus 7 is 28, 288 28/100. 288 28/100 meters squared, because we're talking about area and it needs to be square units. All right, moving right along. We also have triangular prisms. So in a triangular prism, we're going to have the triangular bases, and it's going to be connected by a rectangle here at the bottom, the left, and the right. You kind of see it three-dimensional. Now, since we have triangles that are the same size, we can just do it once. Now remember the formula for the area of a triangle. Area of the triangle is area equals the length of the base times the height divided by 2. So if I'm looking, well, the base is 5, the height is 9. 5 times 9 is 45. Okay? So if I am thinking, okay, so 45 divided by 2, so if I want to come over here, 45 divided by 2, because the base was 5, the height was 9. 5 times 9 is 45 divided by 2. 2 can go into 4 twice. 2 times 2 is 4. 4 minus 4 is 0. Drop the 5. 2 can go into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. Can't have any left over, so I add a decimal 0. I bring my decimal straight up. I bring my 0 down. 2 can go into 10. 5 times, and I know there's none left over because 2 times 5 is 10. All right, so the two triangles are 22 and 5/10. Now, when I look at my rectangles, it's not like a rectangular prism where they're all the same size. I see that this one here at the bottom is going to be 13 times 5. I see that this one here is going to be 13 times 11. I see that this one over here, there's no measurement here or here, but if this is 13, I know that's 13. So that one back there is going to be 13 times 9. So let's start with 13 times 5 to do the bottom one. We're going to do 13 times 5. Well, 5 times 3 is 15. Put the 5 down, carry the 1. 5 times 1 is 5, plus the 1 is 6. So I figured that both of my triangles are 22.5. So I'm going to start my list. There's one of my triangles. I have another congruent triangle. Congruent means that it's the same. This one here at the bottom, this 6th grade, you have to stay organized in these problems. You can't just do whatever you want to with the numbers. 13 times 5, 65. So here at the bottom, we get 65. Now, if I'm looking at this one up here, I'm going to have 13 times 11. Well, so I'm going to come over here. I'm going to do 13 times 11. Well, 1 times 3 is 3. 1 times 1 is 1. I'm going to put the 0 down. 1 times 3 is 3. 1 times 1 is 1. Going to add these numbers. 3 plus 0 is 3. 1 plus 3 is 4. Nothing in 1 is 1. I get 143. So I need to add that to my list. Notice if I want to, I can put 0.0. It's not necessary, but maybe for organization, it's a good idea. So now I've got to deal with this one here in the back. I've done the 13 times 5, which is this one here at the bottom. I've done my big one over here, which is 13 times 11. But now I got to do this one here to the left, which is going to be the 13 times 9. I'm going to come down here, 13 times 9. 9 times 3 is 27. Put the 7 down, carry the 2. 9 times 1 is 9. Plus 2 is 11. We get 117. So we're going to come over here and we're going to add 117 and 0/10 to the list. Well, let's add. 5 plus 5 is 10. Still 10, still 10, still 10. Put the 0 down, drop the decimal, carry the 1 from the 10. 1 plus 2 is 3. Plus 2 is 5. Plus 5 is 10. Plus 3 is 13. Plus 7 is 20. Put the 0 down, carry the 2. 2 plus 2 is 4. Plus 2 is 6. Plus 6 is 12. Plus 4 is 16. Plus 1 is 17. Put the 7 down, carry the 1. 1 plus 1 plus 1 is 3. 370.0, and it's inches, so that's going to be inches squared. All right, moving right along. This tent looks like a tent, essentially what it is, but it's still a triangular prism with a triangle here in the front and the back, and then we have a rectangle here to the right, a rectangle here to the left, and a rectangular base. The one thing about this particular type of triangular prism, though, is that with this being the 4 1/7 and this being the 3 2/3, you can see that this one on the right and this one on the left, with this being a right angle, that being the middle, the one in the rectangles on this big one here that you see on the right and this one tucked away in here on the left are going to be the same size. And so that's going to be, for area of a rectangle, 3 2/3 times 4 1/2. Because just like we did on the previous one, for rectangles it's going to be length times width. For triangles it's going to be base times height divided by 2. So let's deal with this 3 2/3 times 4 1/2 for this one here on the right and this one here on the left. So I come over here, 3 2/3 times 4 1/2. So this is not just finding surface area of a triangular prism, you're also reminding yourselves how to go about multiplying mixed numbers. Well, everything has to become a fraction. 3 times 3 is 9, plus 2 is 11, 11 over 3. 2 times 4 is 8, plus 1 is 9, 9 over 2. I can cross-check a 3 and a 9. 3 divided by 3 is 1. 9 divided by 3 is 3. I get 11 times 3 is 33. 1 times 2 is 2. If I simplify that, 2 can actually go into 33 16 times. There would be 1 left over. My denominator is 2, 16 1/2. So this big rectangle here to the right, this one here to the left are both 16 1/2. So I'm going to come over here, 16 1/2, 16 1/2, just to keep organized. Notice, sixth graders, how I'm not afraid to take up space, how I'm not afraid to show my work, keep myself organized. Now, if I look at this rectangle here at the bottom, that's going to be this 4 1/7 times this 3 2/3. So that's the next problem I need to do. I need to do this 4 1/7 times 3 2/3. Process is going to be the same. Everything's got to become a fraction. 7 times 4 is 28, plus 1 is 29. That's going to become 29 over 7. Okay? 3 times 3 is 9, plus 2 is 11, 11 over 3. Well, nothing besides 1 can go into both 29 and 3. Nothing besides 1 can go into both 7 and 11. So, well, I know that 7 times 3 is 21. If I come over here and do 29 times 11, sometimes I'm going to have to do some scratch work. 1 times 9 is 9. 1 times 2 is 2. Put the 0 down. 1 times 9 is 9. 1 times 2 is 2. Okay. 9 plus 0 is 9. 2 plus 9 is 11. Put the 1 down, carry the 1. 1 plus 2 is 3. So I get 319. But then that's going to involve 21 going into 319. I actually have to do this division problem. Well, 21 cannot go into 3, but it can go into 31 once. 1 times 21 is 21. 31 minus 21 is 10. I bring down the 9. Now, what I should have done at the beginning is round that 21 to 20 to work with the smaller number 2. Now, 2 can go into 10 5 times. So I'm going to try 21 times 5 to see if that gets me about where I want to be. 5 times 1 is 5. 5 times 2 is 10. I get 105. I like that. That's less than 109. So I'm going to put 5 minus 105, and I'm going to put the 4 down. 21 can go into 319 15 times. There's 4 left over. My denominator is going to be 21. So I come over here, and I end up with 15 and 4 over 21. Because as we said, it can go in 15 times. That's the whole number. There's 4 left over. That's the numerator. I was dividing by 21. That was the numerator here. It's what I was dividing by. I get that there. Now, I can't forget about my triangles. I have these two triangles, the right and the left, that were the same size. That's the 16 and a half. The one here at the bottom, that's the 15 and 4 over 21. Then I have this one at the front, this one at the back. 4 and 1/7 times 2 and 1/3. That's the height. This is not the height. It's not times the 4 and a half. The height is the distance from top to bottom. That's why this 2 and 1/3. So it's 4 and 1/7 times 2 and 1/3. Well, 7 times 4 is 28, plus the 1 is 29. So we're back to working with 29 over 7. 3 times 2 is 6, plus 1 is 7. So I get 7 over 3. Well, I like that because my 7s can cancel each other out, and those can become 1s. Now, I can't cross-check a 3 and a 29. Nothing goes into 1, or nothing goes into either of both of those except 1. So I just have to work with that. 29 times 1 is 29. 1 times 3 is 3. 3 can go into 29 9 times. There's 2 left over. My denominator here is 3. So I get 9 and 2/3. But remember, for the area of a triangle, you have to divide it by 2. Okay? So this actually becomes 9 and 2/3 divided by 2. Well, 3 times 9 is 27, plus 2 is 29. 29 over 3. This would be 2 over 1, so it's times 1 over 2. Okay, remember, I'm dividing by 2 over 1. That becomes a multiplication sign. You flip it to make the reciprocal. 29 times 1 is 29. 3 times 2 is 6. Well, 6 can go into 29 4 times. There are 5 left over because 6 times 4 is 24. And it would take 5 more to get up to 29. My denominator here is 6. 2 triangles, both have an area of 4 and 5/6, 4 and 5/6. So, we need to find some space here. I'm going to find a blank spot. So we had our 2 triangles, 2 rectangles that were the same, 16 and a half, 16 and a half. I'm bringing all those numbers over. The bottom rectangle was that 15 and 4 over 21. And then I had both my 2 triangles that are congruent at 4 and 5/6. Well, to find the surface area, I have to add them all together. Now remember, when you add fractions, you have to find a common denominator. I've got 2, 21, and 6. That's going to take some effort to find a common denominator. But there's a simple trick to do that. Trying to find a common multiple, always use the biggest number. So start with 21. Well, 21 times 1 is 21. It's not going to work. 21 does not show up in the 6 times tables. 21 is not an even number to be divisible by 2. 21 times 2 is 42. Well, I know that 6 times 7 is 42. So I like that. And I know that it is an even number because it ends in 2. So I can make everything 42. This is going to become 16 and something over 42. Well, what did I do to get 42? Well, I multiplied it by 21. So I have to do 1 times 21. 1 times 21 is 21. So this one also becomes 16 and 21 over 42. This has to become 15 and something over 42. Well, what did I do to 21 to get 42? I multiplied it by 2. 4 times 2 is 8. So this one also, that's 15 and 8 over 42. This one has to become 4 and something over 42. Well, what did I do to 6 to get 42? Well, I multiplied it by 7. So I'm going to do 5 times 7. 5 times 7 is 35. This one also is going to become 4 and 35 over 42. Well, here's some addition work that needs to happen now. 21, 21, 8, 35, and 35. Well, 21 plus 21 is going to give me 42. For the purpose of time, I'm going to kind of accelerate this, but you may sometimes have to do some scratch work. 21 plus 21 is 42, plus 8 is 50, plus 35 is 85, plus 35 more is 120. That's going to be 120 over 42. When I add my whole numbers, 16 plus 16 is 32, plus 15 is 47, plus 4 is 51, plus 4 more is 55. Also, I got to simplify. Both of those numbers are even, so I can divide them by 2. 120 divided by 2, well, 12 divided by 2 is 6. And so 120 divided by 2 is 60. 42 divided by 2 is going to be 21. Well, I know that both of these numbers are divisible by 3 because 6 is divisible by 3, and I know that 21 shows up in the 3 times tables. So once again, I can simplify. 60 divided by 3 is going to be 20 because 6 divided by 3 is 2. Add the 0, you get 20. 21 divided by 3 is 7. Well, there's no number besides 1 that can go into both 20 and 7. 7 can go into 20 2 times. If I take 7 into 20 2 times, there are 6 left over. My denominator is 7. But I can't forget about the 55. I have to add that to my 2, which means that I end up with 57 because 55 plus 2 is 57. And 6/7. Remember, we were working with the unit feet. So it's feet squared. There's a lot of work that goes into that, 6th graders. You got to keep yourself organized. You have to remember the things that we've done in class. Most of the ones you have to do on your assignment aren't that difficult. But this just shows you got to keep yourself organized and the process you have to go through. All right. Talk to you later, 6th grade. Bye.